Okay, hi. So to continue our lecture, so now let's do 8.2 equilibrium of a uniform rigid body. Okay, so we've learned in our previous video, okay, there's a relationship between the linear motion to the rotational motion. So I'm going to state this very early that torque, which is defined as tau here, it's analogous. Okay, analogous means that it's similar to force. Okay, force. So the torque is analogous to the force. So let's see the definition of torque. So what's the definition? It's a tendency of a force to rotate an object, or, so there's three definitions, or the turning effect produced by force. So you can write it as a tendency of a force to rotate an object about an axis, or the turning effect produced by force. Or, this is my favorite definition, it's the cross product between the distance r and the force F. Okay, so this is my favorite definition. There's three definitions you can use, but actually the third one is the best definition. Is the cross product between distance r and force F. So here, as you can see in our example, okay, you have here a man which is trying to tighten the screw here. So he is moving with a force F here, and also distance from the point of the screw, which is we will call this point the pivot point, and the distance from the pivot point to the hand is r. So if you want to find the torque, which is the tendency to rotate, okay, tendency of object to rotate, it's the force crossed with the r, which is the distance of a force to the screw here. Okay, so how do we elaborate this? So we have learned in chapter 1 the cross product. If you were to have the cross product tau equals to r cross f, it's fr sine theta. Okay, it's different from the dot product which you learned in chapter 5. Work. So the dot product is a cos, whereas the cross product is a sine. Okay, keep that in mind. So we have here torque. Okay, torque F is the force applied, R is the distance from the point of rotation to the point where the force is applied, which I stated before, and you have theta here, which is the angle between the force and the R okay, the distance from the point of rotation. So the point of rotation, the other thing that I said here, instead of calling it the point of rotation, we call it as a pivot point. So the quick way to imagine this is you imagine a door. Okay, if you push the door forward, you would always push it further from the pivot point. Okay, the part you try to push a door, okay, opposite to the doorknob, you can't push the door because it's near the pivot point. So basically the pivot point is the point where you push the force, it can't move. Okay, it cannot move. All right, so from here you have force F here and R. So the angle between force and R is what we call the angle theta. Okay, and the SI unit is in meter because you have force and R meter, and it's a vector quantity, means that it has direction, also magnitude. Okay, an important thing to note here is the direction. Okay, if it's moving, if the torque is moving anti-clockwise, it's positive. If the torque is moving clockwise, it's negative. So how do we determine this? Okay, how do we determine this? Okay, so you see here, see you have force here. Okay, it would usually move towards the direction of the pivot point. So as you can see here, we have a force here. It usually moves to the direction of the pivot, which is the shortest direction. Okay, shortest direction. So it moves here because it is shorter. Okay, it does not move here because that would take longer for the force to move pivot. So the force would move towards the pivot point in the shortest direction. So it would move here in an anti-clockwise direction. So when it's anti-clockwise, so the torque is positive. All right. Okay, so you have there. Okay, positive torque and negative torque. So positive if it's anti-clockwise, negative if it's clockwise, right? So the next part we're going to learn is the static equilibrium of a uniform rigid body. So why do we study this? We study this because we want to analyze, again, we want to analyze rotational motion. Okay, so to better analyze the rotational motion, you need the body to be in a state of equilibrium. Okay, for the body to be in a state of equilibrium, there's two conditions. Okay, there's two conditions that you need to achieve. Okay, there's two conditions that you need to achieve. The first condition for it to achieve is the summation of the force acting on the body is 0. Summation of F equals to 0. And since it's a net force, you have X component and the Y component. Okay, so we will learn in the next slide. There's quite a lot of forces involved in this chapter. Okay, but I'll show it a bit, because for problem solving you'll do that inside your tutorial. Okay, so for the second part, the second condition for equilibrium, okay, is the summation of a torque equals 0. Why do we want summation of a torque equals 0? Again, because we want to achieve rotational equilibrium. So to achieve rotational equilibrium, we must assume that the summation of the torque equals to 0. Okay, so here are the problem solving strategies. Again, this will be explained in more details inside your tutorial class, but I will give a few pointers on how do you solve problems in equilibrium of rigid body. So as you can see, okay, as you can see in your right hand side here, you have people here. Okay, never mind that. Let's see here. Okay, this is a good example of equilibrium of a rigid body. Usually here they want you to find basically the unknowns here lah. Okay, basically they want you to find probably the mass or the length or things like that lah. So as you can see here, we have a person standing on a ladder. Alright, so here there's two things that you need to know at point here and point here. Okay, at the point N and the point N, so you can choose which point you want to be as the pivot. So again, I would state that the pivot is the point where the thing does not move. So usually, logically, when you stand on a ladder, the pivot point would be this point. Okay, so again, from this point, you would have a normal force moving upwards, a frictional force moving to the right, because the ladder should move a bit to the left. Then from this person, it must have mass since it's a person. So it has weight moving downwards, and you have a normal force pushing upwards to the left. So since we're dealing with forces, you need to draw the free body diagram. Okay, since we're dealing with forces. Okay, then what you need to do is you need to pick a point of rotational point. So again, it's called rotational point, but in this lecture I would call it as a pivot point. Okay, you can choose the point here and here, any point, but again I would suggest you choose the point where the thing does not move much, which is this point lah. Alright, does not move. Okay, choose. Okay, another tip here which you can do is you choose a point where the most unknown force passes through the rotational axis. Okay, so it means that, let's say if you were to choose this point, means that you have around one forces, or basically two, but from here you can again have 1, 2, or probably 3 forces. So again, this is the ideal point. So apply our condition for equilibrium from our last slide. Okay, so summation of torque equals to 0. Since we know that torque equals to force F cross R, which is Fr, which is, okay, let me write that down, which is which is Fr sine, okay, sine theta. Okay, you need to note that the force, okay, depends on how many forces are involved. So from here you can see that there's 1, 2, 3 and 4, so probably there's plus F2 R sine theta. Okay, what's the R here again? Is the distance of the force. Okay, let's say the force is mg. Okay, mg. Okay, mg here. Okay, mg here is the distance from the force here to the pivot point. Okay, that's R. Okay, and again, it must move to the shortest distance, so it would move mg is downward, should move over there. Okay, so it's an anti-clockwise. So it's a clockwise, right? So a clockwise, this should be negative. Okay, because weight is downward here. Again, it should move towards the pivot. Okay, so weight is here, mg. Okay, mg. So it should move towards the pivot point there. So moving, creating a clockwise, right? So this one is negative. So a thing you need to know, even though it's submission, we know that submission is a plus, right? But it depends on the rotation of the torque. Again, if it's in the clockwise, it's negative. If it's an anti-clockwise, it's a positive. So bear that in mind, right? So, and again, it depends on how many forces are involved. So probably plus n r sine theta, etc. lah. So I won't do much more since there's no question here, but you should explore this lah inside your tutorial. Okay, next, you choose a convenient x and y axis to resolve the problem, because as you can see here, there's sometimes there's angle involved. So okay, pause on the angle. As you can see here, you have a normal moving outwards, the frictional moving right, you have a weight moving downwards, normal moving to the left. So you have x and y components. So you need to resolve that into x and y component, and then you apply summation of f equals to summation fx equals to 0, summation fy equals 0. You can have the value of the force or the mass, or depend on what the question asks, and you solve equation in 3 and 5 to determine the unknown. Again, the unknown can be anything from mass to length, depends on the type of question. Okay, so that's all for now. In the next video, I would like to introduce you to rotational dynamics. Okay, hope you enjoy. Bye.